Dear guests, welcome to the Artificial Intelligence program in Health Science. Today we are together with Mr. Roberto Saracco. Roberto, welcome to our program.
Thank you.
Thank you very much. I know you, but we want to know you together. So please can you introduce yourself a little and please explain your artificial intelligence story, all the guests.
Okay, thank you, Emel. As you can see, I'm pretty old. I've been working in many areas, in research, in telecommunication, and I work in industry. I work with the World Bank in Latin America and so on. And all through these years, I've been participating in the IEEE work. In the last 3 years, I've been responsible for co-chairing an interesting initiative that's called Digital Reality. It's part of the Future Direction Committee. And in this initiative, we have been studying digital twins and their application to various areas, including healthcare. And of course, during the pandemic, our focus has accelerated in a way, has been sharpened onto the healthcare area. So this is what I'm planning to do today, just presenting you what we have been doing, and I hope it can be of interest to your audience.
Thank you very much.
So without any further ado, I'm going to talk a little bit about healthcare future. Now, it's a very big area, okay? It's difficult to talk about the future of healthcare. So I'm just trying to focus on some specific topics, and particularly how to use digital twins in this area, how to create and use personal digital twins, and I will end up with a chatbot, talking about the chatbots. Now, in a nutshell, my presentation is going to be structured in 4 parts. The first part is about the digital transformation. Again, it's a very broad area, and I'm going to focus on the role of digital twins in digital transformation. Then I'm going to focus on personal digital twins, and of course, their role in healthcare. Then we're going to look at the application of digital twin and personal digital twin to epidemics. It's a hot topic, of course. So it makes sense for me to close the first part of my presentation in this area. And then the fourth slot will be dedicated to looking a little bit about the future. Okay, what's going to happen in the future? What's going to be the role of digital twin and personal digital twin in the future? Now, as you can see in the graphic there, we are actually seeing a progress, a tremendous effort toward digital health. This is basically to reduce cost and become more effective. And also, we are seeing more and more focus on precision health. Rather than creating a pill that can be swallowed by everybody, we're going to try to create a pill that is just right for you. So this is precision health, okay? How can we do this? Well, we do this by using data. And so it's just appropriate that I start my presentation talking about the digital transformation. Now, what is digital transformation? Digital transformation is all about data, data and data. And as you can see in the picture on the right-hand side, we live in a world of atoms. But by using sensors, we're able to mirror these atoms into bits. We are creating data that are reflecting to a certain extent the atoms we are living in. And of course, as we usually say in Italy, by the end of the day, you want to eat spaghetti. So what you need to do is to transform the bits into atoms. And this is something we can do with actuators. Now, putting all this together is the digital transformation. And the digital transformation so is about harvesting data, storing them, making sense out of data, understanding what the meaning of data, and then, of course, to act on this data, to do something about this kind of thing. Now, digital transformation has been occurring and in different fields, and it has taken different approaches in different sectors. We have had the industry that really started this kind of process. We're seeing it in healthcare, we're seeing it in entertainment, in tourism, in cities, and so on. Each individual sector has its own interpretation of the digital transformation, but they all have in common the fact that they are doing this because they want to lower costs and they want to increase efficiency. At the same time, as you're doing this transformation, you are looking into a situation that is going to be different from the one we have today. So what we are facing is a potential for disruptions. That is basically the rules of the game are going to change. Now, let's look at the digital twin concept, and let's go back to this picture that I showed you in the very beginning, where we have these atoms that are captured in forms of bits. And then what we want to do is to use these bits. We want to use these bits for mirroring the physical world, for modeling it, for understanding it, and for trying to do something. And here there's a lot of artificial intelligence, because all these data are difficult to manage unless you're using some sort of mechanical processing. And of course, artificial intelligence provides us with this kind of machinery to analyze data and to create meaning out of data. Now, digital twins are all around this space. And what is different in a digital twin from data? Because, you know, we have plenty of databases. So in my description saying, okay, we're taking atoms, we're converting them in bits and we're storing them, well, that's a database. So what's the difference with the digital twin? Well, a database is there. It contains our data. We can look at this data. A digital twin similarly contains data, but is in sync with the physical reality. So every data you're seeing contained in a digital twin is actually connected by an invisible thread to the physical entity. And you can be sure that when you're looking at that data representing that entity, it is like you're just looking at the entity itself, because it's exactly the same. So the synchronization is actually a crucial part. And of course, the other thing is that you want to use this digital twin to help you act on the physical space. So you're looking at the digital space, you're doing your thinking, you're using artificial intelligence, and then you say, okay, let's do something on the physical space. And the digital twin may act as a bridge. So it's a two-way bridge. It's a bridge from atoms to digital and a bridge from digital to atoms. Now, you can also look at this digital twin as bits using virtual reality. And this you can see in the diagram there, VR, virtual reality. And you can also use this digital twin along with the physical entity using AR, augmented reality. So that by looking at the physical entity at the same time, you can also see the digital space associated to that entity. And this is something that is being done more and more in many fields by, I don't know, people that have to fix an airplane. Okay, the airplane, the engines are very complex. They use goggles, and they are looking through the goggles at the engine. At the same time, they are seeing the information that is coming through the digital twin on their eyes, and they can see these kind of things together. So augmented reality is another way of using digital twins. Now, what is then a digital twin? Basically, is a three-component set. The first part is a digital model. You want to model the car. You see, here we have a car. We want to have a model of that car. And that's the digital shadow. The digital shadow is actually representing the car as it is at this particular moment. So look here, you have the Tesla being produced. And as it is being produced, it generates its own digital twin. And then the Tesla is being driven on the road. And that digital twin remains connected to the Tesla so that it knows exactly where the Tesla are, how it's working, how much petrol it's consuming, and all this kind of thing. This is the shadowing of the thing. And then you have the third component, which is the thread, meaning that the digital twin remembers all the story of this car. And if you can go back, so you have a problem now with the car, you can go back using the digital twin and see where this problem generated. Why did it happen? Okay, you just go back in that. Now you put all these three things together and you get a digital twin. Now, digital twin have been used first in industry. It started in the first decade of this century, and industry is a major utilization, makes a major use of digital twins. But now they are being used in several other areas. And as you can expect, when something is successful, is being used more and more, it gets evolved. It evolves over time. And you're seeing here in this diagram showing that at the first thing, it was just a representation of the physical stuff. But then it became something that followed the physical stuff and got a journal with the physical stuff. And then it came to a stage, which is the third stage we're living basically today, where the physical entity is continuously updating the digital entity, and the digital entity is updating the physical entity, acting continuously on that. In the fourth stage, we're going to see an overlapping of the two, so that some of the functionality that you're going to experience, as an example with your car, are not actually in your car, but they are provided by the digital twin. And then we're going to move to a fifth stage and then to a sixth stage, where basically we are going to get more and more autonomy of the digital twin, okay? Now, all of this is made possible because we have much greater possibility of processing. We can inject artificial intelligence inside the digital twin, so it becomes smart, okay? It becomes actually smarter than the car, and the car can use the smartness to do more things. Okay, so this is the kind of thing that is happening, and you see the arrow there, embedded AI. AI, artificial intelligence, is going to become embedded. Now, let me give you an example of use, because it might be easier to understand. You see this guy here, he's operating a backhoe. And the way he's operating the backhoe, you see, he has a screen in front of him. That's because Mevea, who is the company that is producing the backhoe, when receives an order, they start to develop the digital twin of that machine. Not the machine, only the digital twin, the model of the machine. And then they call in the customer and have him sitting there and say, okay, try to use this machine. It's a virtual machine, it doesn't exist, okay? And they are showing the customer exactly the same environment where he will be using the machine. So he's using the machine and he's saying, oh, I don't like this one thing, I would like to have this kind of thing differently, and so on. Once there's an agreement of the type of specification, after he tried out the machine, then they build the machine and then they deliver the machine. But the customer is going on with the digital version of the machine so that he can use the digital version to train the workers, starting to use the machine before the machine is even there. And when they are receiving the machine, they are already trained, so they can start right away and use the machine, okay? And more than that, the machine is equipped with the IoT, with Internet of Things, so that it can report back all the information, and Mevea can follow what's going on and tell, okay, we should change something perhaps, okay? And they can fine tuning. So this is the way the digital twin enters from the very beginning, from the design stage to the operation stage. And they are threading it all together, creating a single thing. Now, a digital twin, and this is important, can also be used to represent a virtual entity, like a city. Well, I know a city is a physical thing, okay, but it's so big that when you're talking about the city, you're talking about the abstract concept of a city, okay? You're not thinking about that tree, that road, or something like that. Well, a digital twin can do the same thing. You can use the digital twin to map a city, the city of Singapore, as a digital twin, starting January 1st, 2019. And they are using the digital twin to design expansion to the city, to design transportation, and simulating what may happen. And also they're using the digital twin when something happened to see what they can do in order to solve the problem. So they're using the digital twin to simulate a situation based on the current situation of the city. Okay. Now, another thing, of course, since we're here for healthcare, okay, for healthcare is, well, yes, they can be used in healthcare. And actually, General Electric, vice president responsible for healthcare, he said that 3 years ago, well, digital twin are going to change completely the landscape of healthcare. And they are already using it for monitoring, managing hospital wards, okay? And see the flow of resources, and manage of waste and all this kind of thing. They are being used, and General Electric are actually delivering equipment like MRI, okay? Equipped with a digital twin so that the doctors and nurses can try the machine even before they have the machine delivered. And then they can follow and operate the machine through the digital twin. They can be used as an assistant to surgeons, and they can be used in training, in medical training. Stanford University is using digital twin for training the future doctors. Okay, so there are plenty of application in the healthcare. Now the question is, how can you create a digital twin? Well, in industry, it's pretty straightforward, because in industry they're using CAD, computer-aided design, and CAM, computer-aided manufacturing, for producing the goods. So as they are designing the stuff of the computer, at the same time, the digital twin is being created. And then they can use VR, virtual reality goggles, to look at the design. And they can even look at the design from different places, different engineers in different locations. They can look at the future car they are designing using VR. And then when they start the production, they are putting Internet of Things, sensors inside the car to connect with the digital twin, so that when the car is in operation, is driving, well, they know what's happening to the car, and they can follow and can provide maintenance and so on. All of these things are hosted on platform like MindSphere from Siemens, so that they have a continuous monitoring of what is going on. And by using open interfaces, they allow third parties to step in and provide other services through the digital twin. So you can get more services on your car because Tesla is opening up the digital twin of the car through third service provider.
Thank you very much for this amazing presentation. Thank you.